So my name's Trent. I'm a senior academic at Torrens University. I have this amazing job where I get to like think about and talk about and play games and design games all day, every day. It's a lot of fun and it's really good. And I feel privileged to just have a chance to share that with you guys. I'm hoping that I get to show you a little bit about game development. We don't have a huge amount of time, so it's going to be like at breakneck speeds. But I'm hoping that you get a little bit of insight about what it's all about, how some certain things work. And the goal for today was really to basically jump into League, have a look at a feature in League, and then see if we can replicate that in Unity. Now, hopefully I haven't timed out a League. We're very close, so we'll switch over to League. And today we're going to be looking at just a really simple part of a MOBA, right? So I've been playing MOBAs like forever. I've had to take a break because you guys know how addicting it is and how much time it takes up. And unfortunately, when you become kind of like an older adult and you get a little bit of gray hair, MOBAs take up a huge amount of time. But I'm really familiar with the mechanics, so I understand how they work. I'm not a huge LoL person myself. I used to play a lot of Dota and a lot of Hon. But minions are part of that, right? So minions are all about sort of getting your XP, and they go down the lane and they do a whole bunch of stuff. So let's have a look at how the minions work in League, and then we'll see if we can replicate some things, and we'll kind of break down sort of what's going on. So if I go and spawn some minions, first thing is we see like 4 or 5 minions spawn one at a time at a certain point here. So we'll keep that in mind. And the next thing that we notice is that they immediately start walking down a path as if they know exactly where to go. And if you've got any sort of familiarity with game development, game design, you might know that this is what we would call pathfinding. All right, so we'll just destroy these guys and we'll start again. So we think about, well, where are they going? What are they doing? When they spawn, they're basically given a directive, right? So the little brains are told, you need to go here. And they need to understand the world around them. They need to know how to get there, what's an obstacle, because they might just decide to walk through an object. So the thing about game development and about software engineering in general is that you realize very quickly that computers are not smart. They're actually quite dumb. And it's our goal as programmers and software engineers and designers to give meaning to a computer. So everything we see, we have to do, right? So the AI and how it works, we have to actually program it and design it and make it work the way we want. And that goes for these guys, these little minions. So they're following basic instructions. And for them, their main goal is to come down the lane, whatever lane they're in, and eventually reach the end. So they're going to get to the end here, and they're going to change what we'd call their state. All right, so we'll have a look at how to set this up. But most AI works off what we call a state machine. And so a state machine is like thinking about breaking up your day into tasks. Like if I ask you guys like what you did today, you might tell me you woke up, you had breakfast, you went to school, or maybe you didn't go to school at the moment. And these patterns would be pretty familiar. And so you could think about, well, if I was to describe at any point what I'm doing, well, maybe I'm, eating. Maybe I'm walking, maybe I'm, going to school. And it's no different for these minions. They have really basic states where it might be like traveling or walking or pathfinding or attacking. And we'll have a look at how we might break that down in code, right? I won't get too deep on that, but I'll show you how we might set that up. And my Annie's auto attacking. And then we'll look at sort of how it all comes together. So how those sort of features work and play off each other. All right, so we're going to jump into Unity and I'm going to close League. Unfortunately, I know you probably would love to see me play really badly, but I am not good. So I promise it is not worth your time. I'm going to be using Unity today. Now, the great thing about Unity and the Unreal Engine, these are game development packages. We'd call them off-the-shelf packages because they're not proprietary. There's things that can be bought, or they're things that are freely accessible. And they give you a lot of features and a lot of power, and it helps you get up and moving really quickly. We could start in C++. We could, write our own game engine, but we would be here for about 6 to 12 months before we actually got to the point of where we want to get to today. And that point is what I'm going to show you on the screen. So I'm going to show you where we're going, and then we're going to wind it back a bit. We're going to sort of unpackage it and deconstruct it, and then see if we can build it back up again. So what I've got here is basically a whole bunch of, just simple assets that describe kind of like a MOBA type world, and I've got my little minions spawning and walking down, you know, my impromptu lane. And they're going to keep going down here all the way down until they get to this guy. And it's just a lovely tower. Once they get to this tower, they're going to try to attack it and eventually get itself down to 0. And if this was an actual MOBA, they would move on to the next tower. There would be champions and other enemies to fight and minions to combat against. But at the moment, they simply come down here. They're pretty dumb, but they got a little bit of intelligence. So they know that they need to go somewhere and that there's a certain way to get there. And then they've got something to attack. Now, it might seem pretty simple at first. Maybe you're thinking, oh yeah, that's pretty straightforward. I could do that. That's great. If that's the case, I hope that maybe there's something about this process and maybe some of the pipeline stuff I discussed for you today that's interesting. If not, you might look at that and think, how could you possibly do that? So wherever you are, I'm hoping I can reveal a little bit of the secrets. I don't claim to have worked for Riot or anything like that, but I have many years now working in game development and teaching game development and understanding how all this stuff kind of works. So we're going to switch now from this Unity scene, which is all pretty and has all the graphics, to something that doesn't look as pretty. And that's this. Unfortunately, a lot of game development, at least at the very beginning, looks like this. This is what we would just call a simple prototype. And the whole idea here is that when we think about how games work, we often think about the visuals, right? So we look at a game, it looks great, it looks amazing. We always talk about the graphics and the fidelity and the aesthetics. We say how realistic it is. You know, a lot of the criticism coming out, for instance, about Cyberpunk at the moment is like, oh, it looks good, but it's kind of starting to look a little bit like dated, a little bit PS4 old gen, instead of thinking about, you know, PS5. And what we don't think about is what's going on under the hood, because we just don't often know. We don't know what the programming is that's involved and the technicalities. So we're very visual, and that's okay. But as developers, we have to kind of sometimes take a step back from the visuals and think, well, we need to get it functioning first. We need to get something that works. And then what we find is that the aesthetic look or the visuals come later, and we can layer them up, right? So we get like this skeleton that works and runs around and attacks and does stuff, and then we get it on top of each other. All right, so what have we got here? We have basically the most boring looking game that you've ever seen, which is, if I hit play, even more boring than it actually looks because nothing happens. So what we need is some of those key elements that we saw before, right? So we had a tower, right? So we thought, okay, there's a tower to attack. We've got a path here and we need some minions. So I've already gone ahead, like any good cooking show, and I've already prepped the minions for us, and I'm going to drag them into the scene. And as you can see, I've updated the visuals just a little bit, and they are represented now by a really aesthetically pleasing capsule. Now, this capsule is really common in most game development circles and game engines, which represent some sort of character or human form. And that's because we don't actually need to worry about legs and arms. Those animations and the visuals, they actually sort of come later, as I mentioned, and they don't actually interact with the world in the way we think about it. Most of the time, it's all simplified, whether it's a character running around in NBA 2K or in League of Legends, or a car in Rocket League. It's all fake. Sorry to ruin it for you, but it's all kind of smoke and mirrors. And in this case, this is our first smoke and mirrors. We've got this capsule, and this capsule basically has functionality built into it that we can't see yet unless we look at what's called the Unity Inspector, which is like a magnifying glass. And that lets us have a look at this particular game object and have a look at how it's built. What are the things that make it what it does? And in our case, for a minion, there are two main things that we want. So on the right here, we've got something called a Nav Mesh agent. And this is all about navigation. And this is all about navigating the world and being able to do that thing that we mentioned before called pathfinding. And pathfinding and steering behaviors are probably the most essential and the oldest forms of like AI in games. And still, most of the time when we talk about AI in games, that's what we're talking about. We're talking about these agents navigating a world in some way, understanding it. And that's what this component does, and there's a whole bunch of settings that we can change for that. The second is this one that I've written for this very purpose, which is the Minion Script, right? This is the Minion logic. This is the brains of our guy or girl. And this is what tells him or she or it what to do and when to do it. And there's a whole bunch of information here that can be changed. In this case, you know, we have a list of towers. So for instance, if I bring this tower guy in here, right, I've got our tower asset, and I'll put it down the end here somewhere. Right. And so this will be what we'll be targeting. And so we'll tell our minion, okay, we want to go to the tower, right? So the tower is going to be where we're going. And let's hit play and we'll see if anything changes. All right, nothing too much has changes. We've got some great errors, which is always good. So we still need a little bit of work. Now let's have a look at what we've got here. So this tower has some waypoints built into it, but they're facing all the way out here. So I'm going to go ahead and rotate this guy. And you're going to see now I've got these 1, 2, 3, 4 little purple balls, right? And these guys are kind of our little, you know, placeholders as waypoints. And so what I want is my minion basically to walk between these points. And so this, when I hit play, I'm just going to go ahead and hit pause. Basically these errors that we see, which are in a programming sense a good thing, are telling us that something's missing. And the thing that's missing in this case is that the waypoints. So even though I've given him a target, he doesn't yet know how to get there. So we have to do a little bit more work. Now, the other thing that's missing from the equation is that we might say, this is where you need to go, but we haven't yet told the AI, well, how do you understand the world? Like you and I look at this and we get it. You know, we get that this is a surface and this is a wall, but our AI doesn't. So what we need to do is we need to build something that the AI can understand. In this case, we're going to build something called a Nav Mesh, right? And so this Nav Mesh, if I head over to my navigation settings over here, I'll just bring them up so that we can see them. Our Nav Mesh allows us to do what we call a bake. And this basically you'll see in a second when I hit bake. Hold on. This builds what is understandable for the AI in terms of space to walk in. So you and I would look at this and we would know that's a wall, but for the AI to know that, it needs boundaries. And so what we can do in Unity, we can save a lot of time and we can build what's called a nav mesh for our nav agent to work within. Now, this is the world that the AI understands, is this navigation space, not necessarily the walls and not necessarily all the assets that we have in there. And we'll see that even in our more complicated scene later on, we still have what is quite a simple nav mesh for our AI to walk around. And all the visuals, the things that we see and understand, it basically ignores those and is just looking for this space. The next thing is we need these waypoints. Now, if I hit play now, it still's looking for the waypoints. And so what we need to say is, okay, what are those waypoints? So I'm going to go ahead here and put in 4 waypoints. And those waypoints at the moment are sitting just underneath this tower. So the great thing about this setup that I have at the moment is that we can just click and drag these in. Now there are lots of ways to automate this, and I do have some of that built into here, but for the moment what I want to do is to show you how we can customize a setup like this. And the whole idea is that in the end, with game development we want modularity and flexibility. So when we build something like a minion or a tower or a champion, we want it so that we don't just have one of those, but we want to be able to think, well, what if I wanted to make 10? Or in the case of League, what if I wanted to make 200, right? And if you wanted to make 200 champions, building them each from scratch every time would be really difficult and time consuming. So most of the time we have kind of like a template. And that's what we're aiming for often, is these templates that are really flexible, that allow us to build things kind of like in a factory, so that we can kind of take the bits we need and put them together into something new. All right, so we'll try again. Let's go ahead and hit play. All right, and so we've got one last error, right? So one last error, and that's going to give us a chance to actually have a look at this script. So it's saying that there's something missing, right? There's something missing from this equation. So we're going to go ahead now and have a look at the script and the logic for our minion, and that'll give us a little bit more understanding about how the minion works and maybe what it is that's missing in this case. Now, for anyone that's programmed before, you might look at this and think, right? That makes sense. I get it. If you've never programmed before, it might actually look like a different language, like complete gibberish. So let me give you just a really brief overview and try to explain it in a way that will hopefully make sense in the context that we're in. Everything we see here at the beginning, these are called members or variables. This is all the information about a minion, right? So remember we said that computers are dumb, so we need to define what it is a minion is. How much health does a minion have? How much attack speed? How fast can they attack? In this case, if we look at our minion, they have an attack damage of 15 and an attack speed of 2. And if we think of that as 2 seconds, well, we can work out our DPS, right? So then we could say, well, if every 2 seconds we're doing 15 damage, well, then every 1 second we're going to be doing half that. Or every 10 seconds we'll do more than that. If we increase the speed, so if we say, well, actually, what if I want the attack speed to be 1 every 1 second? Well, now we're doing 15 damage per second. And there's a whole bunch of other settings here. We have things like how quickly the brain works. We have references to other components. So we're kind of like building this minion piece by piece in code. Now, one of the most important parts of this minion is its brain. So this minion has a brain that allows it to either work slowly or work at a per frame rate. The reason we might want to do that comes down to efficiency. So sometimes having an AI do something every frame of your game, like all the time, can bring your system to its knees. It might not seem like it, but pathfinding and all these other algorithms can be computationally taxing on a PC. So if you have lots of minions or lots of AI elements, you might need to slow them down a bit so the decision making is a little bit slower. And that overall, combined with all the aesthetics, will just make it a little bit more efficient for your game, and it'll have it running at a higher frame rate. So in our case, we have a brain timer, and it's based off something we called a tick. So it's just a really simple pattern where we just have a timer ticking down. When the timer reaches 0, we do what's called a tick, and that allows us to execute some code. In our case, we have everything encapsulated, right, in something called AI logic. And this is what we call our state machine. So in AI terms, our state machine is just a bunch of what we'll see here is switch cases, which say, well, if my minion is idle, do this. If my minion is walking, do this. If my minion's looking for a path, do this. And if it's attacking, do that. And so basically this tells us that if everything comes down and boils down to our logic, then our AI will only be doing one of these things at any given time. It won't be doing both. It won't be doing 3 of them. It'll just be doing one of them. And now if we're going to create a more complex AI system, we could layer these states on top of each other. We could have an animation state machine, a logic state machine. We could have a state machine just devoted to attacking. And they might all play off each other. But they would all be their own little independent systems, and they'd be quite modular. And that helps us kind of break down the thinking patterns of how our AI, in this case, would work. If we keep going a little bit further down, we can see that, well, the things that the AI does are actually not all that complicated. A function in programming terms is all about functionality. It's an input-output system. You put something in, maybe, something happens, and then we get something that outputs from that. It's a mathematical term. But in our case, we just think of functions as our doing things. So what does our minion do? What do they need to do? In my case, well, there's a few functions here that are, all around aggro and attacking. So this helps, do our calculations. Have we been attacked in the last 5 minutes, 5 seconds, 1 second? Who's attacking me now? Is the tower attacking me? All the things we would see in LOL, all of that aggro calculations, well, we might put that in a function, and the output might be a target. So we might say, well, in the last few seconds, the maximum amount of damage has come from, this champion, and they're within range, so therefore I'm going to attack them. Once they move out of range, well, the aggro slips from them and might revert back to a default state, which is the tower. And so an aggro calculator in that case would be doing all that work, and it would be doing it maybe every frame or every few frames or every couple of seconds, depending on the update. And the other thing our AI needs to do is, well, understand where to go and what to do. And that's where this functionality comes into place, where we're just checking, well, is the tower still alive? Is it up? Which tower do I need to go to? And if so, well, if I'm there, maybe I'll start attacking it. If I'm not going to the tower, well, maybe I need to check my waypoints and see what the next waypoint is on the way to the tower. Yep, it absolutely is C#. Yeah, so this is C# within the Unity context. And that's it. So we have a bunch of code here, a few hundred lines of code, but within that, we're doing quite a lot, right? And there's a lot of complexity in there, and there's a lot of things that can go on. I'm more than happy to sort of clean this up and the project and share with you guys later on Discord or another format a little bit more detail about how this stuff works, so you can pick my brain about it. If you're interested, C# is an amazing language to work with. It's a lot more friendly, a lot easier to use. There is absolutely nothing wrong with working in C++. In fact, we teach C++. And if you do software engineering with us or any university that uses computer science, you'll normally learn C++ because it's the most efficient language for developing game engines. Now, if you're already working with an existing engine like Unity, C# is a lot more friendly and a lot quicker to get up and running. So in terms of mobile development or Windows development, C# works really well. Of course, if you learn C++ or C#, they're going to be really useful for you because it'll help you understand other languages that you might step into, like Java or even JavaScript, or scripting languages like Python. Wherever you start, it's going to help. All right, so let's keep going and let's head back now into our project. And we had this error, so let's actually double check what our error is. So we just go to line 43 and it says, well, we're missing something in this tower list, right? So I'm going to head back and have a look what that might be. And I think it has to do with this tower. So we're just missing something from here. Let's have a look, line 43. Okay. So I'm missing a little thing that I did last minute, which is always the case. So I'm going to chuck that in. And it's just this little game manager, which has a little tower on it. Okay. Also, game development is mainly about solving problems. So as you can see, even in a practice scenario, we run into problems. Now, there we have our capsule moving between our waypoints, and eventually he's going to get to the end. And if you cast your mind back to the more visually pleasing one we saw before, it's essentially the same functionality. We've removed all of the sort of noise of the visuals, and we've distilled it down to just really simple logic. Waypoints, a minion that moves between them and moves to a location. Now, how do we take this and how do we translate it to something that we are more familiar with? Because we've got about 5 minutes left. So let's see if we can rebuild this and have a look at it now with all the visual elements and break it down one last level in terms of aesthetics. Okay, so we're back to our more visually basic, and you can see the first thing that you see is my navigation mesh. So despite the fact of all the complexities I have here, my navigation mesh is actually built on just a really simple flat plane. And this plane's been shaped to be the size that it needs to be, but everything that the AI needs to know about navigating this world at the moment is confined to this space. The other thing we already have here is our tower all the way at the end here. Our tower's ready to go. Our tower has some health. Let's give it a few, maybe let's make it 5,000 health. And let's come back to the end. The second thing that we didn't have before was a spawner. So we could add in our minions one by one, but because of time, what I've got here is I've got a little spawner. And this spawner basically takes our template of our AI character and says, every 1 second or just under a second, spawn in 4, right? So it's going to spawn in one, spawn in another, spawn in another, spawn in another. And then after that, it's going to go into a cycle. And the cycle might be that general, minion timer that you would think about in LoL. Like, when's the next wave coming? And when that next wave comes, we get another 4 minions spawn. So in this case, we've said, well, let's go ahead and spawn in our minions. So I'm going to go ahead and hit play. Wait a few seconds. And there we go. 1, 2, 3, 4. But these guys look a little bit different to the other ones. So what's different about them? Well, not a whole lot. So if I go ahead and grab my minion from my scene, right? I've got my minion here. This is what we saw in the other scene. Let me just turn off this nav mesh. It's just a capsule. All the logic's there, but the visuals are actually hiding underneath. Now the visuals are hiding underneath in what's called a child game object. So this child game object called Orc Shaman, these are just assets that I've gotten from the Unity store, which I'll actually put in the Discord as well. I'll give you a whole bunch of links to where you can get all of this stuff and how you can put it together yourself. And it's just sitting under there. And if we turn it on, we'll see that it's actually just sitting there on top of the capsule. The capsule is just a representation for us so that we can see some logic. So for instance, if I turn off the orc and I go to my minion and I actually turn the capsule off as well, and I hit play, if I go to my scene, we can actually see the ghost of my minion walking around. It's functioning and understanding the world and performing all the logic that it would be, but it just has no visuals to represent that to the player. And again, I can't emphasize this more, and it's often one of the things that I keep coming back to with students when they first start learning, is that once you realize that you can break down and separate, your visuals and your logic, it becomes a lot easier to develop a game, because you can start to understand things in how they work and then worry about how they look later. So speaking of getting them to look how they look, we'll go back, we'll turn off, we'll keep our capsule off, and we'll bring our orc on. Now our orc actually has an animator. So the way this orc works is quite simple. If we have a look, it has 3 animations, and we're only actually using 2 of them. One of them is called the blend tree, it's movement. So basically we have our orc here. Our orc has a walk speed. Our orc has a run speed. And depending on how fast the orc is moving, we'll blend between those 2 states. So whether we're going fast or slow, we can actually blend between whether we're walking or running. And the other ones we have is just our spell attack. So our spell attack just gets called each time that we actually need to attack the tower. And again, this is our visual layer. So in our code, our logic says attack, do 15 damage. But then part of that is, also play this animation. And then the player has the benefit of putting 2 and 2 together. They see damage happen, they see a visual that represents it, and that's how we get gameplay. And if I had a particle system coming out at the end and a little ball of flames hitting the tower, it would all be for show. At the end of the day, what we're really doing is doing all the calculations, especially in a game like LoL that has to probably spend more time doing calculations devoid of physics and devoid of collisions and more about accuracy, more happening behind the scene. All right, so that's our orc. So we can go ahead, remove him, and we're going to do one last thing, which is look at how our AI works when we change things up, when we actually maybe add some things into the scene. And this will be how we finish. So in our case, when we hit play, we have our 4 or 5 orcs spawn. And they've got it pretty easy. They're walking down this path and there's not really much to avoid. What we could do is say, well, what if the player, or what if an element like a tree falls down within the scene? Well, what could we expect our AI to do? Will they get confused? Well, if we go ahead and let's create something like, create a capsule. And we're going to take this capsule and we're going to move it somewhere down here, make it nice and big. We had a capsule like this, and it might be getting in the way. Well, how could we get our AI to avoid it? Well, there's a few different ways. One of them is that we could say, well, treat this like another agent, or treat them like an obstacle. I'm going to make this an agent, so it's kind of like a dynamic object. We could think of this like some other big boss creature. I'm going to hit play. And then when my orcs spawn, we'll have a look and see what they do. So this might be moving around, and you can see they actually start to walk around it. And each time I move this in relation to them, you can see these big purple arrows. So what's actually going on is these guys are constantly trying to avoid each other so that they don't run into each other, and they're trying to avoid other objects that are similar to them. And that's it. So there's a lot more that we could unpack and look at, but my time is up, unfortunately. But I want to encourage you, everything that we've looked at today, apart from, say, the coding, most of it is built into Unity in a really user-friendly way. So once you kind of get how Unity works, how these systems work, you can see that something like the AI behind the minions is actually pretty straightforward to put together. And it's kind of like working with Lego. And that's the great thing about game dev, is that once you know what all the Lego pieces do, it's all about putting them together and making your own game. I didn't spend a huge amount of time on this, and I'm already a few steps to creating my own MOBA. It was one of the very first things I did when I was at uni in terms of major projects as well, was I made a MOBA because I wanted to understand how do MOBAs work, because I spent so much time doing them, and I got to unpack a lot of this stuff. I hope you guys enjoyed that, or at least found something interesting about it. Please hit me up on Discord. I'm on the Meta server. We have all our other servers. I'm more than happy to answer questions and whatnot. I hope I didn't miss too much in the chat. I saw lots of stuff going on. But thanks, guys. So we'll finish up there. And if you have anything else that you want to talk to me about, just DM me or talk to me on Discord. See ya.